Welcome everyone. In this video lecture, I will discuss about invariant subspace of a vector space. So let T be a linear operator on a vector space V. This is a finite dimensional vector space. Okay. We always consider a vector space to be finite dimensional. Let me write this again. Vector space V. A subspace W of V is called a T-invariant. We also call it as T-invariant subspace of V if TW is a subset of W itself. Means if you find the image of any element V, that image belongs to W for all the elements V belongs to W. Let's understand this by a figure. Let's draw a diagram for it. We have a vector space V. This is another set. Both are the same. And we have a mapping from vector space V to V. Okay. T is a linear operator. And here we have a subset W of this vector space. Here also we have the same subset of vector space. If we are able to find any element here whose image also lies here, and this holds true for every element lying in this set, then we call this subset as a T-invariant subset or T-invariant subspace of V. Okay. Very trivial examples of invariant subspaces are we have this singleton zero, the zero vector, and the vector space V itself. These two are trivial invariant subspaces of the vector space V. How? You can see that if you find the image of the zero vector, that will be zero by the property of linear operator, and this belongs to this set itself. So T0 is 0 by the property of linear operator, and the 0 belongs to this 0 set. 0 is nothing but a 0 vector. So 0 is invariant subspace. Okay. And for V, if you take any element V, small v, then if you find the image of this element, and T is a linear operator from vector space V to V itself, so obviously the image will lies in this set V itself. For every element V belongs to V, implies V is, or you can say that TV is subset of Here we'll take capital V if we talk about the subset. So we'll take capital T. TV is a subset of V. Okay. If you write the element here, then you will write belongs to V. Okay. So this implies V is T-invariant subspace of V. Okay. Let's take another example. Another example is RT and NT. RT is called the range of T and NT is called null space of T. How we defined RT? RT is defined as all the images of the elements in vector space V. जितनी भी images का collection है, जैसे आपके पास दो सेट है यहाँ पर, ये V है और ये भी V है and this is T. तो यहाँ पर जितने भी एलिमेंट्स हैं, वो जिन एलिमेंट्स पर मैप हो रहे हैं, उन एलिमेंट्स के कलेक्शन को हम रेंज कहते हैं. तो यहाँ पर RT is a set consisting of all the elements W and these elements are such that TV is equal to W. They are the images of the elements lying in the set V. Okay. So this is called range of T. अब हम इसको कैसे कहेंगे कि ये इनवेरिएंट सबस्पेस है वेक्टर स्पेस का. आप कोई भी एलिमेंट RT का लेंगे और उसकी इमेज निकालेंगे. ओके. तो लेट्स टेक for any element V belongs to RT, suppose the element denoted by V. V also belongs to vector space V because range is a subset of T. Okay, subset of V. तो कोई भी एलिमेंट जो RT का है वो V का भी होगा. इसका मतलब ये हुआ कि उसकी इमेज RT में ही होगी. Okay. Any element we take from RT and we find its image, that image will definitely belongs to RT. And this element is also the element of the vector space V. Because here is the condition that the element whose image you are finding that belongs to the vector space V. So this element that we take from RT that belongs to V also because RT is a subset of vector space V. RT वेक्टर स्पेस का भी सबसेट है, इसीलिए जो एलिमेंट RT में है वो V में भी होगा. तो अब उस एलिमेंट की आप इमेज निकालेंगे तो वो RT में आपको मिलेगी. RT को ही बिलोंग करेगी क्योंकि आप इमेज के कलेक्शन को ही आप RT से डिनोट कर रहे हो, तो ऑब्वियसली द इमेज विल बिलोंग्स टू RT. So this implies RT is T-invariant subspace of V. Next one is NT. NT is null space of T. How we define the null space? Null space is the set which consists of those members which are mapping to zero vector. Okay, those members of the vector space V which are mapping to zero vector, जो वेक्टर्स जीरो वेक्टर्स पर मैप होते हैं, ऐसे वेक्टर्स के कलेक्शन को हम नल स्पेस ऑफ टी कहते हैं। तो इसमें जीरो तो हो गई, जीरो वेक्टर क्यों होगा? बिकॉज टी जीरो इज जीरो ऑलवेज, जीरो तो इसमें हो गई एज टी जीरो इज इक्वल टू जीरो, जीरो तो इसमें हो गई। दिस इज अ नॉन एम्प्टी सेट ऑलवेज बिकॉज ऑफ दिस रीजन। So T0 is 0. Now, if you take any element from NT for any U belongs to NT, we have, हमें ये शो करना है कि TU is also belongs to NT. So if you find the image of this vector U, TU will be, क्योंकि आपने NT से लिया है तो TU जीरो के बराबर हो गई, और जीरो किसको बिलोंग करता है? जीरो एंटी को बिलोंग करता है, ये अभी हमने शो किया। दिस इम्प्लाइज आप कोई भी मेंबर ले लीजिए एंटी का, उसकी इमेज हमेशा जीरो आएगी, और वो जीरो तो एंटी को बिलोंग कर ही रहा है। तो बिकॉज ऑफ दिस रीजन एंटी इज ऑल्सो टी इनवेरिएंट सबस्पेस ऑफ V. एंटी इज टी इनवेरिएंट सबस्पेस of V. Okay, let's take another example. Suppose we have a linear operator on R3 and it is defined as T A B C is equal to A plus B, B plus C and 0. Show that, हमें ये शो करना है कि जो XY प्लेन है, XY प्लेन को हम कैसे डिफाइन करेंगे? It contains the vectors of the type A, B, 0 and AB belongs to the real numbers. And x-axis. How will you define x-axis? It contains the vector of the type A00. A belongs to R. These two are T-invariant subspaces of R3. ये हमें शो करना है। It is very easy to show that these two are T-invariant subspaces. Because if you take any vector from xy plane, it is of this type, and if you take the image of this vector, by the rule of this image, finding the image criteria, the image of this vector will be A plus B, B and 0. Okay. So its solution is very easy. For any A, B, 0 belongs to xy plane, if we find the image of this vector, it will be A plus B, second coordinate is B plus C, and C is 0, so second will be B. Third one is 0, which belongs to XY plane, because the third coordinate is still 0 here, and these two are this coordinate will lie on x-axis, and this will be on y-axis. So this vector will lie on xy plane. And you take vector from x-axis, its image will be a plus b, so b is 0, so it remains a. B plus c, it remains 0, and 0 belongs to x-axis. So you can see that's very easy. You just take the vector from xy plane, find its image, you will find that the image also lies in the xy plane. So these two are invariant subspaces of R cube. That's all. I hope you understand the topic invariant subspace of vector space V. If you like my lecture, press the like button, and you can also share my lecture. And if you have not subscribed my channel, you can subscribe it to get the notification of any other new topic on this subject. Thank you very much.